This is your lesson on right angle trigonometry. In today's lesson, you will evaluate trig functions of acute angles. Use fundamental trig identities and use a calculator to evaluate functions with minutes and seconds. Okay. Here's our unit circle. Things you should pay attention to is that these ordered pairs represent sine and cosine, with sine being second and cosine being first. I remember this order thinking of alphabetical order, just like X and Y are in alphabetical order, C and S are in alphabetical order. Okay, there's a bunch of reasons why this is cosine and sine. Without going into too technical detail, if you drew a triangle, a right triangle, where the right angle is down here, the angle is here, so this would be my 30 degrees, then the cosine would be adjacent over hypotenuse, and the hypotenuse is always 1. So the adjacent side would be rad 3 over 2, and the opposite side would be a half. So that's how we get these ordered pairs that go all around the unit circle. And if you want to find the tangent of the angle, you just put the sine over the cosine, or y over x. Just like in the slope, you put the y on top and the x on the bottom. So for the tangent of 0 radians or 0 degrees, it'll be 0 over 1, which is just 0. And if you took the tangent of 90 degrees or pi over 2, it would be 1 over 0, which you can't divide by 0, so it would be undefined at this point up here. And then if you just think about all the other ones in here, all the 2's will cancel each other if you put one over the other, right, as a fraction. So all you have is 1 over rad 3, rad 2 over rad 2, which is 1, and rad 3 over 1. Okay, and then all these other ones, just paying attention to the positive and negatives. And from yesterday's video, you remember that all students take calculus, so that will help you remember the sign of or the positive and negative, right? When I say sign, it's kind of confusing because we have a sine function and then we have the sign of a number, which is positive and negative. But everything's positive here, and then in here only the signs are positive. You see how only the signs are positive. Down here, everything's negative except for tangent, because tangent divides the negative by a negative. And then in quadrant 4, you have only the cosine is positive. Okay. Okay. For sine of theta is equal to 3/7, find the cosine and tangent. This sounds awfully difficult because it doesn't seem like you have enough information, but all you have to do is draw yourself a triangle, a right triangle, and then you know that if you have an angle, let's put our angle here, you can put it anywhere you want. You can put it up here, you just can't put it at the right angle. You have two choices. I'm going to put it down here, and I know that sine is opposite over hypotenuse. Okay, so then I have my two pieces of my triangle, and I know this is a right triangle, so I can finish that off with the Pythagorean theorem. Okay, so I know that a squared plus b squared is equal to c squared, so I get a squared is equal to 40, because this is 49 minus 9. Take the square root, and I'm going to get plus or minus square root of 40. But since we're talking about a measurement, I can throw away the negative one, just have square root of 40. And you know you can't leave it like that because there's a 4 in here, or 2 2's times 10. So you take the pair of 2's outside, or take the square root of 4, leaving 4 times 10, leaving the 10 inside, taking the square root of the 4. So that's this side. So now all you have to do is write the cosine. It'll be adjacent over hypotenuse, and the tangent will be opposite over adjacent. And then you just don't write your answers with the denominator with the square root, so just multiply by rad 10 over rad 10 to clean up that square root, and then you get 3 rad 10 over 20. Alright, let's do our second example. Cosine is equal to 0.6. Find the sine and tangent. Well, the last problem we had a fraction. Do you know how to change this one? Alright, you can draw your triangle. We need sides. And this time, just to change it up, I'm going to put the angle at the top. Doesn't really matter where you put it. And we know that 0.6 is 6/10. Reduce this to 3/5. In this problem, you could actually have used the 6/10. It doesn't really matter because it all reduce anyway. But then you have to reduce every single answer. So I reduce it here, and then my sine and tangent will be fine. So cosine is adjacent over hypotenuse. Adjacent to my angle theta would be right there. And the hypotenuse is always the side opposite my right angle. Okay. All right. Pythagorean theorem gives me 4. A squared plus b squared equal to c squared. Sine theta is 4/5. And tangent is 4/3. All right. Okay, filling in this table. Now, you're going to have to know your way around the unit circle. Okay, it says construct a triangle to complete this table. And we have theta between 0 and 90. Like at the beginning of the lesson, I said we're going to be working with only acute angles. And later on, we'll do the obtuse angles. So if we have an acute angle, if you know your way around the unit circle, you won't actually have to draw the triangle. But if you couldn't remember the unit circle, you could draw the angle for cosine, and knowing that the denominator is the hypotenuse and the adjacent side is rad 2, you could use the Pythagorean theorem to figure the rest of this out. Or knowing the unit circle or using a little hand trick, you'll know that these places are at 45 degrees and pi over 4 radians. If you don't believe me, look at the unit circle. You should be memorizing these as we go. Okay? Sine of 30 degrees in radians. You should remember that that's pi over 6. And 30 and pi over 6 for sine on the unit circle should give you 1/2. Now remember that tangent is sine over cosine. Remember the 2's cancel. We're on the unit circle where you get a ratio of rad 3 over 1. So you want a place where the sine is rad 3 over 2 and the cosine is 1/2. And that would be at 60 degrees and pi over 3. Okay, now this is a little trickier because all these are upside down. Remember, cosecant is the reciprocal of sine. So where is the sine value? Rad 2 over 2, right? If you flip this upside down, you have rad 2 over 2. That would be at 45 degrees and pi over 4. Secant is a reciprocal of cosine. So reciprocal cosine, well, you'd first just convert the 30 degrees to radians, and you should have that memorized, hopefully, by now. And then cosine should have been rad 3 over 2. So if you take the reciprocal of that, you can get 2 rad 3 over 3. Okay. And cotangent is the reciprocal of tangent. And we just did that one. Tangent of 60 degrees is rad 3, so this would be 1 over rad 3. Alright. Okay, using your calculator to find these values. I think hopefully you know that this is going to be plus 40 over 60 and then plus 12 over 3, 3600. All you have to do is take the reciprocal. And when you put this in your calculator, you're going to put it in like this. And remember, you actually will have to write it like this in your calculator. And then you back up. You should get 1.0049. Try and give 4 decimal places on these trig functions, just like logarithms, because if you round too much, all these numbers are going to be quite small. So if you don't have enough decimal places, you're going to round to the wrong place. Round too much. Okay. Try this one on your own. See if you can get the cotangent. Okay. So you put in your calculator. Ooh, that's a typo. That should be tangent. 1 over tangent. I thought I looked at this pretty carefully before we started, but apparently not. Okay, that's a tangent of theta. Doing this with my mouse today, so. Ooh, okay. So you're going to have tangent of theta. That means the rest of this may be all messed up too. Oh, okay, I corrected it here. Alright, so this is tangent, and then you put that in your calculator, you'll get 2.3361. Alright, that's it for today. Hope that clarifies it up a little bit. Do the Google form so you can get a little bit of practice before coming into class. Thank you so much.